the problem statement says determine the forces in members GE, GC, and BC. We can make it more fancy by saying of the truss, but I guess it's pretty obvious that we are talking about this specific truss. And it also says indicate whether the members, these members are in tension or compression, I guess. Yeah, it's only two other possibilities. Compression. All right. So let's see what can we do with this. So let's assume that I'm going to make this cut here. The cut is given, but it's kind of obvious because we're looking for forces in member GE, GC, and BC. Well, if you wanted to use joint method, you have to start looking at different joints. So quick question, now you should be comfortable with method of joints. Is there any joint I can start with at this moment without doing anything else? Is there any joint that I can start from? If this was a method of joints, obviously this is not, we are looking at method of sections. But if I wanted to do this using method of joints, is there any joint that I could start with, meeting the specific requirement, right? At least one known and at most two unknown forces? No, Connor says no. Any other opinion? Yeah, I'm glad there is none, because he is correct, right? That's exactly what the situation is. There is no joint we can start from. This one has two internal. This one has three internal, all unknown. This one has multiple internals, all of them unknown. This has one external known, but three unknowns. All these are unknowns at E and C. Exactly, thank you. Exactly. So there is no joint we can start if you wanted to use the method of joint. Let's see what happens if you want to use method of section. Let's say I'm gonna make this cut here, right? This is what it's mentioned, AA. That's the cut. I will get these two. I'll get, let's call this or mention this as section 1, mention this as section 2. I just want to know, well, let's go with the cut and see what happens. So section 1, this gives me something like this. Right, this one, and this one. This is point A. Point A is pin. So there are two unknowns there. Let's just put it there. This is B. This is G. All right, just use a different color so things are a little more obvious. And let's say I don't even know the directions. I just take everything under tension. F, G, E, F, G, C, F, B, C. So this section is not helpful because I have F, G, C, F, F, G, that's E. I can't even read my own handwriting. F, G, E. I don't know F, G, E, I don't know F, G, C, and I don't know F, B, C. At the same time, I don't know these support reactions. I don't know AY and AX. Too many unknowns there. So this section is no useful. It's not useful at all. Let's take a look at section 2. All right, start from there. If it's something along this line. And then we have this one and we have this one. So that would be F. Let's also take them all in tension. That would be F, G, E, F, G, C, and F, B, C. And I have this force here as 400 newtons, this force here as 200 newtons, and then I have this one also on dy. Again, problem. I have, did I miss 1200? Yeah, thank you. 1200. Again, problem. I have four unknowns again. This is just one rigid structure in two rigid body in two-dimensional space in equilibrium. I don't know FGE, I don't know FGC, I don't know FBC, and I don't know dy. So that is also not going to work. So how do I use method of sections now? Where do I start if none of these sections give me enough number of knowns and unknowns? I can afford having three unknowns since it's equilibrium in two-dimensional space. Right? Two directions for forces and one for moment about some point. Right? I can't have more than three unknowns. So what do I do? Yeah, exactly. Thank you, Sama. That's pretty much what I was trying to say in the previous slide, which now you see it. So there is no way I can move forward. The only way to move forward is to actually take a step back before making the cut. Look at the free body diagram of the whole structure. If I do that, I can find AX, AY, and DY. And once I know those, I can use any of these sections to find these forces in members, internal forces. So let's do that. So let me put it right this. We have to start from a free body diagram of the whole truss to find support reactions. And you see, if I don't do it, there is no way I can actually solve this. So I can just separate this as our attempt, failed attempt. And we saw that it's actually not possible to just go. All right, so let's take a look at the free body diagram for the whole truss. Well, let me write it, draw it here. This one, this one, this one. We go with these. That is very much longer than it should be. And then we connect these. Take it that it's connected. And then we have this one and this one. Forces are, let me use different color. Forces of, we have one external force here. We have one external force there. We have support reactions. Let's just put it this way and go with, I know it's in this direction, so I'll just put it that direction. And we have this. Let me put the points A, G, E, B, C, and D. So this is 400 newtons. This is 1200 newtons. This is F. Well, let's just call it dy. Right, the typical way of naming we use. dy. This is AX and AY. All right. Now this is a free body diagram for the whole truss. This is a rigid body in two-dimensional space. We have three unknowns, AX, AY, and dy. We should be able to find all of them using the equation of equilibriums. So summation of forces in X direction should be 0. What do I get from that? Looking at the free body diagram for just the whole structure. 400 minus AX. Exactly. Thank you, guys. So that would be 400 to the positive direction minus A. Well, I should have put, I see, that's a good point. This is AX. I put AY, but I'm glad you guys I should set AX because that is the right direction. I don't know how did that become. How did you guys say AX? AX was in the Y direction, so technically your answer was not correct. Following my freeway diagram, which was also incorrect, but AX is equal to 0. All right, so that gives you AX. AX becomes 400 newtons. This is good. Keep it here. I found one unknown. And I took this as positive direction. How about Y direction? Summation of forces in Y direction is equal to 0. Take this as positive. All right. Exactly. So AY plus DY is equal to, or minus 1200 is equal to 0. So that gives me AY plus DY is equal to 1200 newtons. Good. I got an equation. Relationship between AY and DY. Well, this has two unknowns, so that's not going to work exactly the way I want. What do I do next? How can I find AY and DY? There's only one equation left, and I have to write the moment about some point. Which point do you suggest that I write the moment about? Point A, right? Because I get rid of two forces, so less problem there. So for moment, I'm going to write summation of moment about point A is equal to 0. I take counterclockwise as positive, as that's what I always do. Let's go back, see what we get. So AX and AY has no components in this. DY should be multiplied by the distance, perpendicular distance it has from point A. How much is that? Looking at the truss structure in the picture, it's 12, right? This is 4 meters. So one right here, one right here, the other one right here, the other one right here. So the perpendicular distance between the line of action for dy and the point that I'm finding the moment about A is 12. So that becomes 12 dy. Is it positive or negative? 4 fingers along the line of action, dy, your palm facing the point you're finding the moment about, you're in two-dimensional space. So that gives you, make a fist, or try to make a fist, 4 fingers, the direction they bend, it shows the direction of your moment. And this is the counterclockwise direction, so that's positive. That becomes 12 dy. Right? Let's see what else we have there. We have 1200 newtons and 400 newtons. So what are the moments created by these two external forces? And what is their sign? The 401 is negative, minus, well, it is negative in the direction, that's correct. And it's time multiply the distance, perpendicular distance, it has from point A. Well, look at this force, it's 400. And this is its line of action, right? Yeah, it's 3, exactly. And this is point A, so perpendicular distance between the line of action and the point I'm finding the moment about is 3 meters. So that would be minus my 400 times 3. And looking at the other force, 1200. 1200 is right here. Let me use a different. Is right here. And the distance, perpendicular distance, its line of action has with point A, well, it's this distance, which is 4 meters, 8 meters. And the direction it gives 4 fingers in this direction, so it's also negative. It's clockwise. So that would be minus 1200 times 8. And this is equal to 0. Right? Did everyone follow this? Right? So you should be very comfortable with this at this point. All right, so and that's pretty much it. There is no other force there. So this one will give me dy, and once I know dy, I can go back to this equation. Let's call it star right here. Once I know dy, I can find ay. So dy would be let me double check. What did I get? 900. So this becomes 900 newtons, and it's positive, so the direction we assumed is correct. Then from that equation, once we know this dy, right, we can get, going back there, we know dy 1200 minus 900, right, is 300. So f a y becomes 300 newtons. All right, so we found the support reactions, and now we can use that cut. Right? Now we have the support reactions, we can make the cut. Now, which side you want to go with, it's honestly up to you. I'll go with section 1 on the left side, but you could go with the section 2 on the right side. You should get exactly the same answer, right? Since at this point you have all the forces that you need. Let's take a look at the one on the left and see. Now, section 1, right? Let me try to draw it here. Let me take a look. This one, there you go. So this section 1 becomes, if I'm going to draw it here, is like this. Right, this one and this one. I'll get this vertical one, and I have these ones that are cut. Naming would be A, B, G. Right, this would be A, this would be B, and this is G. Right. I have the force down here downward. So let me just put it here as an external force. I have, well, not actually, this is not external force. This was the support, right? So I actually have those values. So going back to my support, I found AX and AY. Look at the free body diagram of the structure. I found AX to the left. I assumed that to the left, and it turned out to be positive, so that's the right direction. I assumed AY upward, turned out to be positive, so that's also the right direction. So this becomes, AX would be 400, and AY, I found it there, 300. So let's just put them here. This direction, AX is 400 newtons, and AY upward is 300 newtons. Right. All right, almost getting to where we want to be. So this one, again, I don't know the direction, so I'm going to assume that all of them are under tension. I don't want to deal with inspection and figure out which direction each force is. I'll just assume that all of them are in there under tension, all these members, and then we'll find out if the assumption is wrong, we'll get negative value. So that becomes F, I think it was GE, the member there. And the member on this side, I think was GC. I'm going to double check. And this one was FBC. Let me double check. FBC, FGC, and FGE. All right, yeah. So let's see now what we can do. Well, let's just start with the ones that are obvious. Right? Summation of forces in X direction. We have to form these equations. Right? Summation of force in X direction, and let's take this as positive. Let's see what we got here. All right, we have that 400, which is to the left, so minus 400. We have FGE that we assumed is to the right, so let's just put it as positive FGE, FG. We have FBC that we assume is to the right, so that also is positive, FBC. And then we have that FGC, which has an angle with the horizontal line, right? Horizontal or x-axis. To find the component of FGC, obviously we need to know an angle, right? Let's go with this angle. That's what I think is shown. Let's go with this angle. Once I know this angle, let's call this theta. And let's find that theta. Because whatever that theta is, this becomes plus FGC sine theta. Right? Then that's equal to 0. So I do need to find that theta. Let's go back. Tan inverse 4/3. I think that is the case. Let me look at the geometry. This is the angle there, theta, and 4/3. Exactly. 53.13. Yeah, that's, as I said, very common angle. So, yes, thank you, Richard. So theta is tan inverse 4/3, which is 53.13 degrees. If you go back, look at this specific triangle here, like this triangle there, this one. You're looking for theta. From the geometry, the opposite, tan inverse of the opposite over adjacent, right? 4/3. You could find the other angle. This one should give you the same value, but keep in mind that you have to make sure that its sine and cosine is correct when you're decomposing the vector. You could go with that one. I just went with the other one, theta. All right. So I got theta. So here I don't know if GC, I don't know if BC, I don't know if GC. So I have 3 unknowns. There's not that much I can do right there. Let's write the second equation. Let's write the summation of forces in y direction. And take this as positive. All right, I have AY is 300 upward, so positive. What else do I have? What else do you see in the free body diagram for this specific section? What other component we have that participates in forces in y direction? Minus FGC cosine theta. All right, anyone who is not Richard can tell me, or I would say, you know what? Anyone who is not Richard, Samuel, and Elizabeth, and Connor. So aside from these ones, anyone else can tell me what other forces do we have in y direction? So I put AY, it's upward 300 newtons. What else do we have there? Well, we do have FGC, but what would be the component of FGC in y direction? FGC cosine theta. And it would be negative, right? Because it's downward. Exactly. Thank you. So minus FGC cosine theta. And that's pretty much it. Let's go to 0. From here, you can immediately find FGC, as you can see. Right? From these two, from the second one, you can actually find FGC right there. But knowing FGC, if you go back to the first equation, you still don't know BC and FGE. So you have to go for the third equation. Right? The summation of moments. Now, which point is equal to 0? Now, which point I have to choose to find the moments about? Right? Now, what happens is, this is very typical. You will see this. You'll see me doing this over and over. We find a point that two forces are passing. You know, the same story when we were doing, when we were finding moment about, or we were choosing a specific point to find a moment about. The same story is here. This is a rigid body. We have two forces, but well, we can't use A because we don't want to get rid of the known forces. We know AX and AY at this point. So that's the force you want to. That's the point you want to keep in your equation. we want to find the point that we can get rid of at least 2 out of 3 forces, FGE, FGC, and FBC. Now, typically what you see happens when we are using method of sections is that we go and continue these members. We know that's the line of action. We continue the line of action for FGC, and we continue the line of action for FBC in this case. Now, these 2 lines of actions for these forces, we know where do they meet. Right? We know that FGC, the force is exactly along the member GC, and FBC, the force is exactly along the member of BC. So that's where they meet. That's point C. Right? That's where they meet. So this is point C. This is point C. If I find the moment about point C, FGC and FBC are going to be out of the picture. I get rid of 2 unknowns out of 3. And that's good. That's what I was looking for. So I can find FGE. So again, I could do it with point G2. Yes. But that's more conventional than that. That's something you know already. I'm showing you the other option that you will see when you look at a lot of problems that they use method of sections. They go with the extension, right, wherever this the line of action is, right, and then find the moment about that point. But you could go with point G2, right, because point G is also part of this structure. If you go with point G, you can just find the moment about point G. And the FGE and FGC are out of the picture, then you just have FBC pretty much. Because this is a structure that is under equilibrium, so the moment about any point should be 0. So that option is there, I guess. But what you see that happens is that in a lot of cases they go about, they extend this force and they say, well, I know the line of action for FGC is exactly along this member, and I know the line of action for the other force exactly along that member. Where do they meet? Exactly point C. So I'm going to find the moment about point C, and I'll go with the same exact agreement. Counterclockwise is positive. So if you find the moments about point C, well, FBC is gone, FGC is gone. They both pass point C. AX is gone, because AX, look at AX. This is AX, and the line of action for AX is also passing through point C. So 3 forces are already gone. What is left? The only thing left is G and AY. Very straightforward. Now, can someone tell me what are the components I have to put there for moment about point C? Knowing that GC, BC, and AX, their lines of actions pass through point C. And take counterclockwise as positive. So look at this as a rigid body under equilibrium with these forces. Tell me what is the summation of moments about point C, assuming the counterclockwise is positive. And look at the dimensions. I guess I have to take you here. Look at the dimensions. AY times 8, which is the distance exactly from point C. And that would be negative since it's clockwise, exactly. And what else? And we have FGE, remember. What is the distance between the line of action for FGE and the point C? The perpendicular distance. 3. So that would be, thank you. So this is, I'm going to put them here, minus 3. Exactly. Thank you, Dylan. So I'm going to put this here. Oh, that's not the color I wanted to use. I am going to put this here. Trying hard to find the color that we haven't used. This is 8. meters. And keep in mind that this is 3 meters. So if I find the moments, this becomes, as you guys said, minus 3FG minus AY, which is 300 times 8. Minus 8, 300 is equal to 0. Now, if I found the moments at point G, I still would have had AX and AY. So this point is the best, most optimal point, because out of all these forces, 3 are gone. So I have less of, I would say, finding moment or multiplication happening there. All right. So look at these 3. What we've got there. Right? We have 3 equations, 3 unknowns. This is exactly what we were looking for. Right? We have to have enough unknowns for the enough number of equations we have. So 3 unknowns and 3 equations. Now we can find FGC from the second equation directly, F for F summation of forces in Y direction. Once you find FGC, you can find also FGE from the third equation. So they're kind of independent. You can find FG from the third one, FGC from the second one, plug both of them back in the first equation and find FBC. If you do that, I'll just give you the answer. So that would be FGC, I would say, let's just GE and F. So flip the direction. Yes, exactly. That's what we're going to see. If, and this is FBC. So if you find these, obviously, as Samuel said, looking at the third equation, we already know that the direction we took for FG is incorrect, right? Because FG is going to be negative. It becomes minus 800 newtons. So this means that since I assumed all the members are under tension at the beginning and put the forces in these directions, and FG turned out to be negative, this tells me if member G is under compression. So let me put it right here. Direction should be flipped. And that means that this member is under compression. That assumption was not. FGC becomes 300. Let me see. Over that cosine theta, I got, hopefully didn't make any mistake or typos there, 500 newtons. And FBC, I got 800 newtons. These two turn out to be positive, so the assumption were correct. So based on these, I can say, so BC or GC under tension, because that was the assumption. GE, the direction turned out to be wrong, so that's under compression. And BC is also under tension.